Hello everyone, my name is Hubert and I'm Android software engineer at Intiv. And today I would like to share with you some of my findings and thoughts when creating a Kotlin-based library. And I need to tell to you that this is my first presentation with such a big audience and international in addition, so please bear with me in any case. So yeah, the topic of this presentation is the adventures of a Kotlin-based library developer. And well, let's go with the presentation then. So basically, as we know, Kotlin loves Java. It's built on top of it and is interoperable. So from Kotlin language, from the Kotlin part, we can easily call the Java code. But does the same feeling apply when running Kotlin on Java? I mean, using Kotlin code from Java code? Well, though Kotlin is interoperable, it's not to be always used the same from Java code base in all cases. Well, let's assume the following. We are developers who are delivering a Java library, and at some point we decide to move it to Kotlin to do this migration. And the question is, what this operation would result in? Well, as we know, Kotlin does some auto-generation stuff under the hood, and now the question is actually, is it safe? Well, in order to be able to answer that question, we need to have a look at one of the cool Java features that is called binary compatibility. Well, what this exactly is? It sounds like we're going to touch some low-level stuff, just like a bit of raw meat. Well, but in truth, it's about replacing the Java compiled classes without recompiling their consumers. So let's have a look. What does it mean actually in practice? So let's consider the following Android project setup demo. Since we are on droidCon, let's assume a mobile application project. So let's assume we have our app application project that makes use of this so-called a jar library that depends on another library we are actually developing. And this dependency is transitive. And we would like to Kotlinize our dependency, our library. And as we know, these libraries will be linked in runtime and both will be compiled into the project that we are building on. Knowing that Kotlin does some things automatically, we need to be aware of what binary compatibility requires to be fulfilled in order to be able to run this configuration safely. So let's have a closer look at what affects the binary compatibility. So if in our library we do some internal changes that are non-exposed, we should be safe. When we add some new APIs, meaning we extend our public API of our library, we still remain backwards binary compatible. But in case we remove any public API declaration, then we will end up in some issues. What exactly breaks the binary compatibility? Let's have a look at the short list of the most common operations that will break this binary compatibility. So the first thing is deleting a public API. So basically, if we remove from our library a class or an interface or an enum, the code that is using any of these APIs will simply either fail in runtime or refuse to compile if we are using this directly in our code. If we delete a public package, this should result in the same, since the package is just a container for all of the above I have mentioned in the first point. If we hide our public API's member, just like field or method, the reference to it will be also no longer reachable. It will also fail. Also, if one of the classes we are having in our public API, we make it abstract, this will result in the implementers that they will not implement this method, and this will cause issues in our runtime. Also, when we rename a public method or a class member, this is equivalent to a signature change, and this means that the existing references will start to fail. Adding some new parameters to the method calls will also result in a signature change, so the result will be exactly the same as in the 0.5. If we change our methods to or other members to be final or static, well, in terms of adding the static modifier, the whole reference way to these members will change, and this makes our code binary incompatible. And if we actually add the final keyword to some of the methods that we expose in our in our library, thus we prevent the methods from being overridden, and we have again issues in the code base we are maintaining. And there are also many more cases that will lead to the binary incompatibility. You will be able to check them under this link here. I will share with you the presentations. In the last slide, I will include the QR code when you will be able to open it. So don't worry, you will be able to access any resource I have used in this presentation. Basically, the rule of thumb in terms of binary compatibility is that what has been seen cannot be really unseen. Or in other words, what you have exposed, that cannot be unexposed. And this might sound a bit hard to us and requires to be very cautious when writing the library code. But fortunately, when Kotlin 1.4 has been released, the authors of the libraries can make use of one of the cool features that make our life easier. And this feature is the so-called library mode that can be enabled in your project when writing some code, especially in your libraries. When you enable this mode, this will force you to provide explicitly the following. First, the visibility modifiers for the members that are public by default. So for example, when you simply omit the visibility modifier, this will result in an issue found by the compiler. And the other thing that you will notice is that the type declarations for member fields and functions return values will be also needed. We always well, maybe not always, but often rely on the type inference algorithm when writing Kotlin code. But in case of designing APIs, it is always very important to provide these types explicitly, so there are no issues that our libraries consumers will face when using our code base. And depending on the check type you actually enable in your library, you can see these being reported as warnings or compile time errors that would prevent you from building actually something that might not be really explicit in terms of exposing clear API. If you are interested in reading more in this topic, feel free to check this link that I provided here. So basically, that's it. If it comes to the overview of binary compatibility, let's now have a look at what actually a simple, let's say so, Kotlin conversion can break. So just going back to our previous thought, we are supposing we convert a Java library to Kotlin. So let's have a look what issues we might face when migrating the code from Java to Kotlin. So the first thing I would like to focus on are named arguments. Having a look at it in Java, when you rename a method parameter name, it is actually not a big deal. You simply change the name and the change is binary compatible. But in Kotlin, this is not the case anymore. And the reason for that is that the named arguments become a part of the API. And let's have a quick look how it looks like in the code base. So let's assume we have such a function that accepts all these parameters, and it looks like this. What actually are the ways we can invoke this method? So we can go with the classic Java approach. That simply looks like providing the method name along with the parameters, the explicit values for them, and this is how it actually looks like usually. The second approach we can do is use these named arguments approach, whereby each value we provide the corresponding parameter name, so that the compiler exactly knows which value refers to which parameter. And this also allows us to use some other cool Kotlin feature, that is unordered list of the parameters for a given function, so that this way you can simply name the parameters in any order you want, and this function will be invoked without any issues. But remember, when you change in your library a single parameter name, this won't be backwards binary compatible, since all other references to them will simply break. Another key point is data classes. I think every single developer who writes Kotlin code knows what data classes are, but let's have a quick overview what it exactly means to us. These are basically POJOs on steroids. They have built-in auto-generation of the equals method and a hashcode method. They have some powerful feature, that is destructuring, and this is highly tied to the component and functions that are being generated under the hood when creating the data classes. And also a copy function is being generated, so that we can easily change single properties for every single data class instance that we would like to change when creating a new instance of it. Now let's have a quick thought how we can safely extend data classes. So the first thing is that we should put new parameters for the data classes at the end, so that the destructuring declaration will work fine, meaning that every single item has its order number and it remains unaffected. These parameters should remain optional. So basically, when create a new instance of a specific data class with old constructor, we are able to run the code without any issues. And if we provide a default value, the code will compile and run and link safely. And once we have created the new parameter for the constructor, we need to remember about the JVM overloads annotation, so that we can simply and safely invoke the old way of the constructor in an old way. So let's have a closer look how it looks like in practice. So let's assume we have the following data class that takes two parameters. The first thing I mentioned before is to put the new parameters in the end of the list. So basically, this is how it looks like. I have put a comma and a next value in the end of the list. Then I said we need to remember to make this value optional. So I am providing here a default value for this in case we don't provide it in our old consumer classes. And in order to make sure we can provide the constructor with two values to our previous consumers, we need to add this JVM overloads annotation to the constructor of this. And well, are we safe yet? I think we could think that we are, but unfortunately we are not safe. And this is due to the copy function that is being generated freshly, and it will get changed anyway. And this is how it looks like under the hood. So if we create the data class in the first form, the copy function, the copy method, as I said before, has been generated with 2 arguments that looks here, that can be seen here in this place. And if we add another parameter to this data class, let's have a look at this copy function that returns the modified data object. Takes here 3 parameters, 1, 2, 3, and this means that all of the other references to this method remain actually faulty. And the pain point here is that there is no copy method that is being generated, like in case of a constructor that could take only 2 parameters. So this is the biggest deal we have to take here. And this leads us to the question if we should resign from using data classes at all. Well, the answer is just like in almost all of the cases in the IT industry, it all depends. We must choose, but we have to choose wisely. I think that data classes is an option for the classes that are not a subject to change over time. And if you think that your class that holds data is about to change over time, well, you need to think about these potential issues you might face when writing Kotlin code. So choose wisely. Another pinpoint is the static members that are being created in our code base. And these are tricky when converting Java code to Kotlin. So let's focus on this utility class that generates random numbers, heavily inspired by this XKCD comic strip. So let's have a closer look at the structure of this class. Let's assume we have here a static final value that is the result, some static non-final value that is a pending value, whatever that is, and some method that returns us this random number we would like to get. So let's also assume we have this consumer of this class that simply prints out the number that is being generated by this method getRandomNumber. So automatically we have converted right now our util class to Kotlin. The fields became properties. These are right now hidden behind proper getters and setters. In terms of the first value, it is only a getter. In the second case, it's also a setter, since this is a var. And thanks to this get convention that we have in our Kotlin code base, we are unfortunately not backwards compatible again. And this is due to the way the objects are being represented in Kotlin bytecode. So in order to reference the static items in Java from the Kotlin static items from Java perspective, from Java language, we need to remember that we need to put the instance field after the name of the class that we reference. And this is a pain point we fortunately can deal with. This is something that is doable with a JVM static annotation that makes the things easier. And this actually allows us to reference this method without any additional instance field that holds the instance of the singleton class. If it comes to the properties, the similar rules apply. As I have mentioned before, the properties are just fields hidden behind getters and setters. So referencing the instance is not enough, since in order to access the value, we also need to follow the convention for getters and put here the get prefix in order to access the pending value thing. And also we need to remember that this is a method, not a field anymore. So we need to remember to put the parentheses after this call. Fortunately, you have the same approach, the similar approach that could allow us remain backwards compatible. We need to remember about this add JVM field annotation here. And thanks to this, we can again get rid of this both instance field and the method convention that we need to put here in order to be able to access this field. So at this moment, we remain binary compatible again. And a bonus here in terms of the const values that are being placed in the objects, just like here, we fortunately don't need to put here any other .instance reference since the const val is a known value that a compile time. So the Kotlin compiler simply knows that this is something that can be written as static final in the binaries. So this lets us referencing it without any actual overhead. Some other topic that also needs to be addressed here is the compatibility between Kotlin versions. So as the language evolves, it is being updated constantly. This is the similar thing I would say that happens to our libraries we are creating. Also, we add new APIs, new functionalities. So we also tend to add new features and change some behavior of some other features. And this also leads us to another point when we need to think about the backwards compatibility. The same applies to Kotlin versions. For example, when bumping from Kotlin 1.2 to 1.3 and 1.3 to 1.4, there are also some changes that we are also in a need to be aware of. But fortunately, JetBrains publishes the compatibility guides between Kotlin versions. So when we migrate between them, we can be simply aware of what exactly is going on. But in terms of using the programming language, we can distinguish between three kinds of backwards incompatibility. The first one is the source incompatibility that prevents us from compiling the code when switching the version. The binary incompatibility, these are the errors that occur at runtime during the linking. And the third kind of incompatibility is the behavioral incompatibility. We cannot really tell easily if it's going to happen since we are unable to tell whether our code will be unable to compile or fail to link at the runtime. But the change will happen under the hood. We can only observe that the result of our code is being a bit different from what we expected to see so far. If you are interested in reading more about this, please feel free to look at this link. This topic is also explained quite well in Kotlin API reference. And also for those who are not really familiar with the semantic versioning, let me give here a quick overview of the good practices regarding publishing the libraries. So if you are about to use a library, you will see the following segments of versions for a certain library. The first segment, second segment, and third one. The first is called major, the second is minor, and the last one is the patch. And the major part should be updated when the API changes are breaking. The minor part should be bumped when adding new features that are backwards compatible, and the patch should be bumped when there are no changes in API but internal fixes only. And knowing that, we should see that the following examples should also follow these rules. So basically, when you update your dependency from 1.0.0 to 1.0.2, this should run quite smoothly. when bumping from 100 to 110, this also should work fine. But if you are bumping some of the library, one of your libraries from, for example, 191 to 200, this might break, but doesn't really need to. This is only the convention that tells you that the changes are going to be big when bumping the major thing. And now at this point, the rules of putting the plus sign in Gradle dependencies just got clear. And the whole specifics for this semantic versioning can be found under this link. So this all leads us to a short summary. The first thing is, the first outcome is that Kotlin is different from Java, and there is no question about it. This is rather kind of obvious. The second question is whether we should build libraries using Kotlin. And well, I think that here we should think about two things. The first thing is that if we are creating a library from scratch, I would say this is a very convenient option, and that brings actually no risk when converting from Java. But when porting the Java libraries, I think we need to take under consideration the potential places where reflection-based approach is needed, especially, for example, in cases when we are building a library that is being consumed from a different technology, like, for example, from Unity 3D engine, when we tend to create wrappers around our libraries. And once we change our API, also these wrappers can change and crash. So I think this is something that is really risky. So after all, we need to consider our potential users' needs before we decide whether convert from Java to Kotlin or not. Here are all the resources I have been using while preparing this presentation. In the next slide, you will see the QR code, so we will be able to access these easily. And basically, that's it. I would like to thank you for the attention at my presentation of my talk. And right now, I'm happy to take the questions if there are any. Okay, so the first question from Alex, can you give some advice for a situation when we must introduce a breaking change? Well, actually, if you are in this case, then definitely I think following the semantic versioning convention will help. And this change, if you apply these rules, then your users of your library will expect this change. So at this point, you can prepare a nice README file with all of the migration guide that would help your consumers while migrating. And I think this should be pretty much it. Another question, did you take a look at Kotlin binary compatibility validator? Seems promising, but it's still in early stages. No, to be honest, I wasn't aware of this, but thanks for pointing it out. I think I'll definitely need to have a closer look. Okay, and the last thing, for data classes, simply changing the order of parameters breaks the binary compatibility. When declaring the data class, yes, just like as I have mentioned for the destructuring declaration, the proper component and functions will start to point to another values, and yes, you're right. So if I wasn't explicit enough, then yes, you're right. Okay, so as far as I can see, we run out of questions. So thank you again for your attention and enjoy the rest of your conference. Thank you.